Right now, when you use AI, you probably open ChatGPT or Gemini AI and start prompting, right? That's great and simple. But if you want to build something real, software that really works for you, you need to stop just talking to one AI and start connecting them together as a team. Imagine one AI that does research to another AI that writes code and the third AI checks the errors. Basically, you have a whole team works for you. This is exactly how real world software companies are building AI products right now. You are a student and preparing for AI engineering or machine learning jobs, and even if you are experienced software employee but still you want to switch to the AI jobs, then these are the architecture patterns you must know in an interview. Today I am going to show 5 basic ways to connect AIs together. And the best part is I am going to share the working code with you so that you can run in your systems and try it yourself. Hello everyone, I am RK. If you really like my efforts, smash that like button. Your support always gives me the motivation and more energy to create next video. Let's go to our lab. These are the blueprints used in serious engineering right now. Sequential, the chain. Hierarchical, the manager. Routing, the traffic controller. Multi-agent, the collaboration team. Autonomous, the self-correcting loop. We will go through each one. I'll give you a dead simple real world analogy for each concept, show you the technical diagram, and then jump straight into the Python code to see it run in live. First, let's look into this sequential pattern. This is the simplest one. To understand this, think of airport security. First, you show your ID, then you scan your bags, then you walk through the metal detector, right? So this is a sequential. It's a strict one-way chain. You cannot skip a step or go out of this order. The output of one step is the required input for the next, right? So in an A context, it looks like the slide on screen. A researcher agent finds the fact, passes them to the writer agent, who passes the draft to the reviewer. It's predictable pipeline. All right, let's look at the code for this chain. Okay, all right, open this collabresearch.google.com. Click on this file, new notebook in drive. Click on this key symbol, add new secret key, Google underscore API key. Value you should get it right. You can get it from AI Studio. Click here, or you can directly open your AI Studio. Click on create API key. Suppose if you don't have any projects like this, then create new project, something like this, pattern, anything it can be. Create project, then you just give any API key name. It can be anything. Then just copy that API key which you created, come here, paste it. Make sure that notebook access. I'll share you this code, don't worry. Just paste it in the first cell. Basically here we are just reading the Google Gemini API key what you pasted here. Make sure that select this notebook access, close this, and we are installing the required dependencies. Click on this play button. It is installing all the dependencies. We are going to use the Gemini 2.5 Flash model. API key loaded, clients initialized. You must see this kind of console here. Basically this is printed here. Okay, done. Now we are going to run the first pattern sequential. Go here, click on code, paste it. You just click on this play button to run it. Before run, let's understand the code. So here we're talking about the sequential pattern, right? The chain. Researcher agent. So this is the one agent, and this is the second agent, writer, and third one is reviewer. So all these are sequential. Now in the same code we'll add the workflow. Now if you run it, first we are calling the researcher agent by passing the topic. This is the topic. Topic is the one actual input, and we are getting one output from the researcher agent that we are giving to the other agent as a input. Then that output we are giving to the other agent as a input. So this is what sequential, and finally this is the output. All right, it is very straightforward. Now let's look into the hierarchical pattern. The best analogy here is restaurant kitchen. Suppose you have a head chef like a manager, and line cooks, the workers. When an order comes in, the head chef does not cook everything, right? The cooks do the work and hand it back to the chef, who puts all in one place together in a plate. On the slide, you see that A version, a manager agent delegates subtasks to specialized worker agent and then compiles their results. Now let's look into the demo. So on the same Colab, click on this code, paste the code which I am going to share. So here there is a copywriter worker, one agent, design worker, other one, and together the manager hierarchical team, right? It is going to take all this work and it is going to print. Let's see. So manager received a request, coffee maker, delegated, worker copywriter, A powered coffee maker, designer creating the visual concept, and finally here hierarchical team. What hierarchical team is doing? Manager is getting the output from the copywriter worker and design worker both. These together he is compiling the final one based on the product request, design output, and finally he is going to return the required result set to the customer. So this is what the end user output. Now routing pattern. Think of a hotel front desk. You call the desk receptionist, okay, as a router picks up. So the receptionist pick the call. If you say I want to order food, they connect you to room service. Suppose if you say I need fresh towels, they connect you to housekeeping. The receptionist does not bring you the towels. Their only job is to classify your request and route you to the right department, right? This is the path. They are routing the request to the right resources. Let's see everything in the demo. On the same Colab, click on code, paste it. This is a route example. Let's run this. You can see, right, analyzing, I want to buy a plan. This is a sales, right? It is not like support. Then it is going to print pricing info for the whatever you want to buy it. That is a sales. This is next prompt. My login failed. So when it is login failed, it is going to be support. So that is where it is going to the decision is support, and it is printed the message for that support related. So whatever the query you are passing, it will come here, and here you can notice that sales specialist here. If condition is there, if it is related to sales, then it is going to hit. If it is related to support, it will hit. Then you might think that how it is related to sales or how it is related to support. This is where that routing workflow will do that for you. So whatever the query, it will come here. It generates the content configuration. By reading it, it will understand the model. Is it related to sales or support? By the classifications, then it will route to the respective agent, right? I hope it's clear. Now let's look into the patterns for multi-agent collaboration. Think of a student group of project. You have a team solving a problem. They don't wait in a line. They work in parallel. One student researches history, the other researches maths, and they do it the same time to finish faster. We want to research a topic very fast in a group. I have two research agents, one focus on technology, the other focus on business. Now let's look into the demo. On the same Colab, click on this code here, add one cell, paste the code which I'm going to share. In this example, you can notice that I have one researcher, but I have two agents, right? Within the same function, agent A working on the tech and agent B business. So both together running going to parallelly. Let's run, and there is a team, okay, starting parallel work, quantum computing. So agent A working on the tech and agent B working on the business. Agent A finished and agent B also finished. And now the team lead combining all these results into single report and they are submitting it. So the work is done very fastly. It is not like sequential. It is a parallel. Whenever we have the time crunch and we want to make the things very faster and there is no dependency, then usually we'll go with the multi-agent. And the final one and last one, number 5, the most powerful pattern, autonomous agents. Basically, it is the best example for robot vacuum cleaner. In our home, robot vacuum cleaners will be there, right? We have plan. It decides to move, act. It moves forward, observe. It bumps into a wall. It observes the failure, makes a new plan, and acts again. It loops until the room is clean. That is how vacuum cleaner works. Now let's look into the demo. Paste it. Here you can notice that autonomous pattern. Okay, we have two agents. One is writing and other one is reviewing. Critic. Here you can notice that run autonomous loop is there and this observer is there. These observers keep on observing whatever this writer agent is written to you. Suppose here what are the instructions? The writer instruction have it. This is the writer instruction, and here you can notice that critic instructions. What are these critic instructions? It always look for must be exactly three sentences. Output JSON should be pass or fail. What is the feedback? That's it. Let's run this, see how it works. So the controller is saying the goal is write a story about robot on Mars. Attempt 1. First time writer is attempting. He given big paragraph. Then it failed because actually the observer is looking for three sentences, not like big one, right? So then failed, it is saying it is failed. The text contains 71 sentences. So now in the second attempt, a writer agent created the three sentences. So that is how autonomous agent works. It keep on attempting until it reaches the right output. Here we hard coded to 4, that's fine since it is a testing one. Alright, let me conclude everything in 1 minute since we completed all these 5 patterns, right? Sequential pattern used when tasks have strict dependencies. Step B cannot until a step A finished. Hierarchical used when a task is too complex for one agent and needs to be broken down into subtasks managed by leader. Routing user when you have different types of user inputs that require different specialties. Multi-agent use when tasks have no dependency on each other and you need speed. Multiple agents works at exactly same time. And finally, number 5, the loop use when the agent needs to self correct or figure out the path to the goal on its own. It tries, fails, and tries until it succeeds. Like a vacuum clean robot. All the code from today is in the description. Run it, break it, and learn from it. See you in the next video. I hope you like this video. Don't forget to like and share this channel with your one friend. That helps to your friend and our channel also. Thank you all.